Alright, today we're going to talk about naming acidic compounds, and we're going to do it two different ways. We're going to name acidic compounds, and we're going to write the formula for the acidic compounds. So in this first section, we're going to go from the chemical name to the chemical formula, and these are the rules that follow. Step 1 is you write an H. Later on we're going to add subscripts to the H to figure out how many hydrogens we need. But step 1, if you know it's an acid, first step is to write an H, because acids always start with an H. Then next you're going to write the anion. Remember that anions are negatively charged ions. These can come in two forms. Anions can be either, be either nonmetals or they can be polyatomic ions. So those are the two different anions that we could have. The first rule when looking at anions, if the name has the ending ic and it starts with hydro, then you know that those hydrogens are going to be bonded to just a regular element. So this is very important to remember. If you see the word hydro starting an acid, then it's just going to be bonded to a regular element. These next two rules are for polyatomic ions. So rules 2 and 3 are for polyatomics. If the ending is ic in the acid name, then the polyatomic ending is ate. An example of this would be like if you had acetic acid. Because the ending of the acid is ic, the polyatomic ion would have the ending ate, so it would be the acetate polyatomic ion. Next, if the ending is us, then the polyatomic ion ending name is ite. An example of this would be like if you had nitrous acid. Because the ending is us, the ending of your polyatomic ion must be ite, so this was the nitrite ion. And then step 4, you're going to add a subscript to the hydrogen to neutralize the anion, so whatever charge your anion was. We're now going to do a few examples of this in order for you to see these steps played out. Alright, so here are our examples. We have phosphoric acid, hydrosulfuric acid, and nitrous acid. So, the first one, phosphoric acid. It doesn't start with hydro, so we know it's going to be a polyatomic ion. And because this acid ends in ic, we know that ic turns into ate. A good way to remember this is if you ate the whole cake, you would get ic. The way to remember the other one, us, comes from ite. The way you remember that is if you took a little bite, it was delicious. So that's how you remember those two common polyatomic ion endings.
I don't understand.
So, phosphoric acid, because it ends in ic, it's really ate. So we write the phosphate polyatomic ion, which is PO4 3 minus. And because it's an acid, we know it's going to start with H. The last step is to balance the charges. Because phosphate has a -3 charge, and hydrogen, being in group 1, has a +1 charge, we are going to need 3 hydrogens to balance out the charge of this negative phosphate, because 3 times that positive is 3 positive, and 3 positive cancels out 3 negative very nicely. So after we've canceled the charges, you can go ahead and erase the charges so that it's a nice, clean looking phosphoric acid. Alright, next step, we have hydrosulfuric acid. Hydrosulfuric acid should actually be named hydrosulfuric acid. If you want to know why, you can come ask me. It's a funny story. Okay, because it starts with hydro, we know that it's going to be just a single atom bonded to that hydrogen. We don't know how many hydrogens yet, so we're just going to put one out front because we know it's an acid. Sulfic sounds a lot like sulfur to me, so this hydrogen is going to be bonded to a sulfur. Now sulfur is in oxygen's family. Everything in oxygen's family has an oxidation number of -2, or 2-. And as you guys know very well, hydrogen has a +1 charge, so we are actually going to need 2 hydrogens, so that 2 times that positive charge is a 2 positive overall, and that 2 positive will cancel out that 2 negative. Once we've identified all those things, we can go ahead and erase our charges so that we're left with a nice, clean hydrosulfuric acid. Last one, we have our nitrous acid. Because there's no hydro here, we know it's not going to be bonded to just a regular element, so it must be bonded to a polyatomic. If you take a little bite, it's delicious. So this nitrous must turn into nitrite, and our nitrite polyatomic ion is NO2 negative. And we know we're going to need a hydrogen out front because it's an acid. Fortunately for us, our hydrogen has a +1 charge, and if our nitrate has a -1 charge, then they cancel each other out nicely, and we can just erase both charges to have a nice, clean looking nitrous acid. Alright, that is converting from the name to the formula. Next we're going to convert from formula to name. Alright, so here we are. Last step. Here we are going from the chemical formula to the chemical name. And so the rules are, if it is just with the element, the prefix is hydro with ic at the end. So, in our 3 example problems, this looks like it's hydrogen, this is hydrogen with a polyatomic ion, this is hydrogen with a polyatomic ion, this is hydrogen with just an element. So this is the one we're going to focus on first. So for rule number 1. Alright, so rule number 1 says if it is just with an element, the prefix is hydro. So the first thing we're going to write is hydro. Then the ending is ic. So if this is nitrogen, nitrogen changes to nitric. So this is hydro nitric, and then at the end you always put acid. So hydronitric acid. Alright, step 2, if it is a polyatomic ion, you change the ending. So this is kind of 2, and this is part A. So, if it's a polyatomic ion that ends in 8, you change the ending to ic acid. And wouldn't you know it, number 2 over here is SO4. SO4 is our polyatomic ion named sulfate because it ends in 8. If you ate the whole cake, you'd get sick. So it is going to turn into sulfuric acid. So it would be sulfate. You would think it would be sulfic. It is not actually sulfic because fic is a dirty word in German. So it is sulfuric acid. Alright, last but certainly not least, so this is kind of 2b. If the polyatomic ion that's found in your acid ends in "ite," you change the ending to "us." So if you take a little bite of cake, it is delicious. If you ate the whole cake, you got sick. So ate is sick. If you take a bite, it's delicious. And lo and behold, we have HClO. And ClO is one of your polyatomic ions called hypochlorite. Because it's hypochlorite, we change the ending to "us." So this becomes hypochlorous, and then the ending, always acid. Alright, those are the rules for naming acids. Good luck. Come in if you have any questions.